You see, there is a CPU like a computer. We also have CPU on routers. Not only on routers, on switches, on all network devices there is a CPU. Some devices have distributed CPU, some devices have got centralized CPU, only one CPU. Some will have a main CPU as a centralized, we call it as route processor, RPE, and there will be some small CPUs on line cards. That's a very big high-end device. Will have many line cards. End of the day, the main processor is what responsible for all decision making. Now, what if that CPU is too much loaded? If that main CPU which makes the decisions is overburdened, it is overburdened because of some sort of attack, some sort of malicious traffic. Normal traffics won't do that overburdening because when they design the device, they have designed by considering the maximum amount of traffic that BGP, OSPF, ISIS, all this protocol can generate. But if there is some abnormalities, if there is some attack, if there is some malicious traffic, intentionally or unintentionally generated, unknowingly generated, this may tamper the CPU, disturb the CPU, so CPU will not be able to work proper. CPU will stop performing well and you will start seeing some network outage. You'll start seeing some performance degradation. So that will definitely impact the whole office. In performance, people will start complaining, and it's going to definitely disturb a lot. The administrators will be in trouble. So what we do is, like we used to write quality of service called policing. When there is an excess traffic, what we do in policing, we drop. We do policing now, not on the interface, but on the control plane. CPU is control plane. Earlier, in quality of service class, we did quality of service for the incoming and outgoing interface traffic. Incoming and outgoing traffic on an interface. Now we are going to set similar QoS for the CPU, for the control plane. So that when excess traffic comes, it will be dropped. As a result, the CPU will not undergo overburden. The performance will not get degraded. Outage can be avoided. See, that's what written in how CoPP works. CoPP applies quality of service policy to the traffic directed towards the control plane, which is CPU. What protocol we have in control plane? Routing protocols. They are the one which decides the forwarding decision, control. So with quality of service policy only, we are now going to limit the amount of traffic that can be generated from BGP, from OSPF, from ISIS, all control plane traffics. We are going to limit them so that no protocol will go and grab the entire CPU and make the other protocol suffer. Yeah. So we are going to use the same MQC, modular quality of service class command line interface, MQC. If you know quality of service, you know class map, you know policy map. Similar to that, in class map, we are going to match all those control plane protocols. In the policy map, we are going to set the limit. And where will you apply this? Not on the interface, but on the control plane. That's all. Let's see. Key components of control plane policy. First, you need to classify. That is class map. We match these protocols. Next is under the policy map, we do policing. We are applying the rate limit to prevent excessive traffic. And then we can go and monitor them. We can see how much of traffic is dropped because of exceeding the limit. Those malicious traffics you can go and monitor. That's verification. Action will be taken if there is excess. And we can go and monitor them by putting some show commands. Here is the example configuration. We have a class map which matches protocol OSPF, BGP, SSH. And we have a policy map under which we call the class map, which is matching OSPF, BGP, and SSH. And we have set the policy saying, police, this is 100 meg, confirm action, transmit, if it exceeds, drop. This number, what to put, you have to decide after monitoring. You need to monitor the traffic in a secured environment, and you should know how much is the maximum these protocols can take. If anything more than that is not from this protocol or it is not normal, so we are going to drop. We don't want CPU to get hanged. If CPU gets hanged, you cannot do anything. You have to restart. Again it will hang. Again you restart. Again it will hang. When the attackers keep on hitting. But when you keep this in limit, when you drop, you will see why it is getting dropped, which traffic. Your CPU will be under control for you to do that verification. You can verify and find the attacker, and we can shut down that port from where the attack is coming or block that particular source. We can freely do something if the CPU is free. If CPU is fully busy, then you will not be able to log in and see the logs. So this is going to keep the CPU utilization under limit. Now these two things you know already, class map and policy map. Now we used to apply the policy map on the interface in quality of service. But in the Control plane policing we do on the control plane. In the global configuration mode, you type the command control plane and call the policy map. This is the policy map. Service policy input, call the policy map under the control. That's simple it is. To verify, this is the command show policy map control plane, show policy map interface control plane. Best practices. Identify and prioritize essential control plane. Control traffic. Use conservative rate limit to avoid accidental service description, meaning you need to know how much to set as a rate limit. Continuously monitor and fine-tune policies. Apply along with other security. So don't only rely on this control plane policing, also put ACLs, reverse path forwarding, unicast reverse path. That's one command. Do these things. Right.